In this lesson, we'll dive into four major theories and hypotheses that shape how we understand the process of learning a new language. We'll also look at how technology and artificial intelligence are transforming language classrooms today. Whether you're a language teacher, learner, or enthusiast, these insights will help you appreciate the science behind language learning and offer practical strategies for your own classroom or study routine. Let's begin by setting the stage for these influential ideas. Our first theory is input processing theory, developed by Bill Van Patten. This theory focuses on how learners process language input, prioritizing meaning before form. According to Van Patten, when exposed to new language, learners naturally focus on content words, those that carry meaning, before paying attention to grammatical details. This approach helps explain why beginners often understand the gist of a sentence even if they miss some grammatical endings or function words. Let's break down the key principles of this theory and see how it applies in real classrooms. The primacy of meaning principle states that learners initially focus on the core message of what they hear or read. This means they pick up on content words, like nouns and main verbs, before noticing smaller grammatical details. For example, in the sentence, "The cat runs quickly," a learner might first understand cat and runs, grasping the main idea, while missing the adverb or verb ending. This natural tendency shapes how teachers should design input activities, ensuring that meaning is clear before drawing attention to form. Another key idea in input processing theory is the first noun principle. Learners often assume that the first noun they encounter in a sentence is the subject. For instance, in "The dog was chased by the cat," beginners might mistakenly think the dog is doing the chasing, simply because dog comes first. This highlights the importance of teaching learners to pay attention to sentence structure and not just word order, especially in languages where word order can be flexible. To put input processing theory into practice, teachers can design tasks that first ensure learners understand the meaning, then gradually shift their attention to form. For example, after reading a story, students might be asked to highlight all the verbs and discuss their endings. This helps learners notice grammatical forms in a meaningful context, reinforcing both comprehension and accuracy. Such activities bridge the gap between understanding and correct usage. Next, we turn to the comprehensible output hypothesis, introduced by Merrill Swain. While much attention in language learning is given to input, what learners hear or read, Swain argues that producing language is equally important. When learners try to speak or write, they notice gaps in their knowledge, test out new forms, and reflect on how to express themselves more accurately. This process, known as output, is crucial for developing fluency and grammatical accuracy. One of the main functions of producing language is noticing. When learners try to express an idea and struggle to find the right words or forms, they become aware of what they don't know. This awareness, or noticing, prompts them to seek out new language or pay closer attention to input. For example, a student trying to describe a past event might realize they're unsure about past tense endings, motivating them to learn more. Another key function of output is hypothesis testing. As learners produce language, they test their assumptions about grammar and vocabulary. For instance, a student might try using a new verb tense in conversation to see if it sounds correct or is understood by others. This trial and error process helps solidify language rules and encourages learners to experiment with new forms in real-life situations. The third function of output is metalinguistic reflection. This means thinking about language itself, its rules, patterns, and structures. After speaking or writing, learners might reflect on what worked, what didn't, and why. This self-awareness leads to deeper understanding and more accurate language use over time. Teachers can encourage this by providing feedback and opportunities for learners to discuss their choices. To apply the comprehensible output hypothesis, teachers can design purposeful speaking and writing tasks. For example, problem-solving discussions or debates require learners to use language actively. After the task, Peer feedback sessions allow students to reflect on their output, notice errors, and try again. This cycle of production, feedback, and reflection is key to building both fluency and accuracy. Let's move on to processability theory, developed by Manfred Pieneman. This theory suggests that learners can only produce grammatical structures they are cognitively ready to process. In other words, there's an internal order to how grammar is acquired, and learners must master simpler structures before moving on to more complex ones. This has important implications for how grammar should be taught in the classroom. According to processability theory, learners acquire grammar in a predictable sequence. They start with basic word order, then move on to inflections like tense and agreement, followed by subordinate clauses, and finally, complex sentences. This sequence is driven by cognitive processing abilities, not just the complexity of the grammar itself. Understanding this helps teachers scaffold instruction and avoid overwhelming students with advanced structures too soon. The first stage in grammatical development is mastering basic word order. Learners begin by forming simple sentences, such as, "I eat apples." At this stage, the focus is on arranging words correctly to convey meaning. Only after this foundation is solid do learners move on to more complex grammatical features. Teachers can support this stage by providing plenty of practice with simple sentence structures. Once learners are comfortable with word order, they begin to notice and use inflections, changes to words that indicate tense, agreement, or number. For example, adding "ed" for past tense or "s" for third-person singular. This stage requires more cognitive processing, as learners must pay attention to both meaning and form. Teachers can help by highlighting these endings in context and providing targeted practice. The next stage involves subordinate clauses, sentences within sentences, like, "I know that she is coming." This requires learners to process more complex sentence structures and connect ideas logically. Mastery of subordinate clauses marks a significant step in language development, as it allows for more nuanced and sophisticated communication. Finally, learners reach the stage of producing fully complex sentences, combining multiple clauses and ideas. For example, "Although it was raining, we went outside because we wanted to play." This level of grammatical sophistication reflects a high degree of cognitive processing and language proficiency. Teachers should introduce these structures gradually, ensuring learners are ready for the challenge. Processability theory suggests that grammar instruction should be sequenced according to learners' cognitive readiness, not just grammatical complexity. Teachers can scaffold learning by starting with simple structures and gradually introducing more complex ones as students are ready. This approach helps prevent frustration and supports steady progress in language development. Now, let's look at how technology and artificial intelligence are shaping second language acquisition. Recent studies show that AI-powered tools, such as speech analyzers and error feedback systems, can provide personalized input and scaffolding for learners. These innovations make language learning more adaptive, efficient, and engaging, offering real-time feedback and tailored practice. AI-powered speech analyzers can evaluate learners' pronunciation, intonation, and fluency in real time. These tools provide instant feedback, helping learners identify areas for improvement and track their progress over time. By integrating such technology into the classroom, teachers can offer more individualized support and motivate students to practice speaking outside of class. Error feedback systems powered by AI can automatically detect and correct grammar, vocabulary, and pronunciation mistakes. These systems help learners notice their errors and provide suggestions for improvement. By receiving immediate, targeted feedback, students can make faster progress and develop greater confidence in their language skills. Adaptive pronunciation apps use AI to tailor practice activities to each learner's needs. These apps analyze speech patterns and adjust exercises to target specific weaknesses. This personalized approach ensures that learners spend more time practicing the skills they need most, leading to more efficient and effective language acquisition. Blended learning environments combine traditional classroom instruction with digital tools and resources. By integrating AI-powered apps and feedback systems, teachers can create a more dynamic and interactive learning experience. This approach allows for greater flexibility, enabling students to practice and receive feedback both in and out of the classroom. One effective classroom activity is the I+1 input workshop. In this exercise, trainees bring texts that are just slightly above the learner's current level. Partners work together to highlight new forms and discuss how prompts make the material comprehensible. This activity encourages learners to stretch their abilities while ensuring that new language is accessible and meaningful. Negotiation practice is another valuable activity. One learner gives directions while their partner asks for clarification. The interaction is recorded and later analyzed for input modifications. This process helps learners become more aware of how language is used in real communication and how meaning can be negotiated through questions and clarifications. In the input processing task, students are presented with sentences containing embedded suffixes. Their job is to identify whether the form contributes to the meaning and then reformulate the sentence if necessary. This activity sharpens learners' awareness of how grammatical forms function in context, bridging the gap between form and meaning. Cue competition analysis involves providing learners with ambiguous sentences. Students interpret these sentences using cues like word order, morphology, and context. This activity helps learners develop strategies for resolving ambiguity and understanding how different language features interact to create meaning. To summarize, we've explored 4 influential theories in second language acquisition: input processing theory, comprehensible output hypothesis, processability theory, and the impact of technology and AI. Each offers unique insights into how languages are learned and provides practical guidance for classroom instruction. By understanding these theories, teachers and learners can make more informed decisions about language learning strategies. Throughout this lesson, we've seen how these theories translate into practical classroom activities. From input workshops to negotiation practice, and from AI-powered feedback to scaffolded grammar instruction, each approach is designed to support learners at every stage of their development. The key is to match activities to learners' needs and readiness, ensuring both challenge and support. Looking ahead, the field of second language acquisition continues to evolve. Advances in technology, especially artificial intelligence, promise even more personalized and effective learning experiences. As research progresses, we can expect new tools and strategies to emerge, further enhancing the way languages are taught and learned around the world. In conclusion, understanding the major theories of second language acquisition and leveraging new technologies can transform language learning for both teachers and students. By focusing on meaningful input, encouraging output, sequencing grammar instruction, and integrating AI tools, we can create more effective and engaging learning environments. Thank you for joining this journey into the science and practice of L2 acquisition.